Thank you very much. So the game at the end of Magic the Gathering, does anyone play Magic the Gathering out there? Yes? I have 120,000 Magic the Gathering cards in the back of my office, and I employ my children as slave labor to sort said cards. But even at $2 an hour, it gets quite expensive. So I built a robot to scan the cards and automatically sort them. So I'm going to talk to you today about the art of the 12-factor application. So some of you may be familiar with the manifesto, the 12-factor manifesto. It was written by Adam Wiggin. He was one of the original founders of Heroku. Heroku was founded 11 years ago. And shortly thereafter, 2.5 years, I believe, they were acquired by Salesforce for over $200 million. So since then, we've been a part of Salesforce, but we keep our unique identity as Heroku, and this is part of what that means to us, what 12-factor application development means. So I'm going to get into the details of those factors individually, but the point is that this is a framework for building applications in a way that makes them easy to manage and scale. And that's, after all, what Heroku is all about. So it's a very easy framework to work with. I'm going to explain it to you. My name is Jonan Scheffler. I'm a developer advocate at Heroku. You can find me on the internet as The Jonan Show. I live up in Portland, Oregon, and it's a very short flight down here, but I'm glad that I get to deal with Portland traffic instead of your traffic. We go 10 miles in Portland, and it takes us like 17 minutes, and we're just whining the whole time, like, oh my gosh. So appreciate your traffic very much, but otherwise, this is a lovely area you have down here. You should check out Portland too, though. Just saying. So the first of these 12 factors I want to talk to you about is a code base. Just with a quick show of hands, how many of you are developers full-time? How many of you are writing code day to day? Okay, and how many of you are technical? You are tangentially related to said development? Okay. How many of you are VCs looking to fund my Lego robot? Okay, great. Come see me afterwards. So your code base for your application, you really want one code base for an application. And these 12 factors, again, they were developed 11 years ago, so some of these may seem like common sense today. And I hope that this is one of them. That if you have an application and it's split up into multiple code bases, you don't have an application anymore, you have a distributed system, right? That's not an application architecture. A single application has a single code base, and the code between multiple environments should be the same, with some obvious caveats that I'll get to in a moment. So you've got one code base, and you have many deploys of that code base. You have a deploy for production, for example, and you have a staging deploy, right? And then you have an old staging deploy, the one the salespeople took over to start doing demos, and you can't actually use as staging anymore, right? Don't give the salespeople access to staging. So that's the first of our 12 factors. You want to have one code base per application. If you have multiple code bases, you have multiple applications. It's a distributed system. This is how you get your code onto Heroku. You say git push Heroku master. So we set up for you using the Heroku CLI. It's a simple installation using Brew if you're on a Mac, or you can download a binary and install it. So you git push Heroku master. We set up a git remote for you, and you give us your code, and then your job is done as a developer. That is the end of the story. There's no logging into your server. There's no SSH, turning off plain text passwords, configuring databases. We handle all of that. The entire infrastructure piece is taken off of your plate. We only care about your code base. But we do require that you have a single code base because you're pushing a Git repository. For us, an application is a single Git repository. So this is an example of how these 12 factors are enforced by the Heroku platform. A lot of people try to build things in an open-ended way. They try not to have opinions, and Heroku is effectively the opposite of that. We're a very opinionated platform because we want to help you do your best work. So our opinions inform your application architecture. Hopefully you'll find that it helps you to build better apps. This is how you get your code onto Heroku. Git push Heroku master. You could rename Heroku to production. You have multiple environments, like I said, right? So you have a production master, and that's how you would get your code up to production. When it's time to ship to production, I don't know if this is your experience or not, but as a developer, when I started out, we once spent 6 hours, 7 hours maybe into the evening deploying to production, because there were configuration files that needed to be copied up and little bits that needed to be twiddled all the way across. And then we had to roll back the original deploy because there was a bug, and then we fixed the code, and then we shipped it again. And we were there until 2 o'clock in the morning or something, shipping our code one time, one production deploy. This is how things used to be done back in the day, right? We have the advantage now of cloud services, and then we can simplify that story significantly. So this is how you get your code base. Dependencies. I want to talk about dependencies a little bit for your application. So your application is not just the code, right? Probably you were a little suspicious of me telling you that our job was to take all of the infrastructure off your hands, right? Your job is done when you push the code, because naturally you have dependencies. A 12-factor application builds all of its dependencies itself. If you have a third-party dependency, that third-party dependency is part of your code base. If it's part of your application, it's part of your code base. Your code base knows how to build it. It knows where to get it. It's vendored. So in the Ruby world, where I'm most familiar, we do this with bundle install. And there are lots of dependency managers. Whatever language you're writing code in, you've got your own dependency management system. But it's not just about having all of those dependencies at the ready, built into your code base. It's also about having them isolated from the rest of the environment. So if, for example, my application expects to find a certain gem, a Postgres gem, and that Postgres gem is supposed to be version 0.5, right? But instead, on the server, someone has already installed 0.7, and I'm not ready to upgrade, but because I'm not using a dependency isolation strategy, then I'm going to be using the 0.7. And suddenly I'm upgraded, surprise, and production goes down. So it's very, very important that all of your dependencies are considered part of your application. And that's the second rule of a 12-factor application, is that dependency management step. Configuration. So I told you earlier about my first deploy and how terrible it was. And getting those configuration files where they needed to go, there were secrets, right? You can't just put your API keys in the code base. If you're using GitHub, maybe it's insecure. That code base could leak pretty easily. It's not a safe place to have secrets. There's a number of other application files you need. In old Rails apps, you needed a database YAML. In current Rails apps, you need a database YAML to set up and tell your application how to connect to the database, right? There's a lot of configuration that happens for your application. But anything that would be secret or external service, all of those need to be handled in configuration. And how Heroku does that is we set them in environment variables. So on Heroku, using the CLI, you can say Heroku config set, and here's your environment variable. And this can be frustrating with you for new users of Heroku. You come along and you've got your password file with all the secrets, and you're thinking, how do I get this file up to my server so that all of my API keys work, right? Well, you don't. You don't trust the file system on Heroku because we consider it entirely disposable. And I'll go into that a little bit more later. But we force you to do it this way because this is a better architecture for your application. What you're talking about are environment configuration. You're talking about environment configuration variables for these applications, whether or not you're storing them in a file. And putting them in files across the file system complicates not only your deployments, but it complicates your story in development when you are sending a Slack message to someone saying, hey, could you send me that secrets file? Could you upload it someplace securely? Probably not very secure. The list goes on and on. Environment variables are where that should live. That's how we feel about it at Heroku. And I think that you will be surprised how easy it is to transition to this strategy. So we'll talk about backing services a little bit. I mentioned that database YAML file as part of your config. So let's say that I think a database is pretty safe assumption for an application to have. If any of you are building applications at your startup that do not have databases, I suspect you're in fact writing a script, and you should look into that. But the data is important, and especially because Heroku assumes that you are in a stateless environment. We need you to store those things if you ever want them back again. You can't depend on your local memory. So let's say that we're going to use a backing service. According to the 12-factor application guidelines, we have our database set up out in another server. It's not on localhost. You don't connect or assume that this dependency, your database, is going to be accessible from any given server, right? So on Heroku, if you wanted to add a Postgres database, you would say Heroku add-ons create, Heroku PostgreSQL hobby dev, right? This is a hobby dev plan. We have multiple plans for Postgres. This is the free one. As with everything on Heroku, we have a free version for you to test things out and play around, and this is certainly enough to host your cloud-connected Waffle Maker, my current project. I'm also looking for funding for the cloud-connected Waffle Maker. I just want to throw that out there. But it runs on a hobby plan on Heroku because it's not very complicated. So you can get started and play with all of these tools, and as you grow, Heroku grows with you. You can scale all of these plans all the way up. So you've got your Postgres, and what this is doing, if you look down a little bit here, is that's setting up a environment variable. That Heroku Postgres red right there, that environment variable is where your database connection string now lives. Right? You have a connection string with a username and password in that environment variable, and that's all you need to connect from any server. You don't need to depend on Postgres being installed on that particular server or the right version of Postgres being installed on that server. And those were all things that we used to do by hand back in the day. If you want to add a Postgres database, this is all it takes on Heroku, and you're done. not just about databases, though. Any backing service you have, obviously your application is going to require a number of services, but every single one of those should be accessed through a connection string in one of those environment variables. Build, release, run. So the premise here is that your application has finite steps to get out into production, right? You build it one time and you get everything all together. You've got all of your vendor dependencies, right? All of your environments set up. You release that, and then you run the application. And on Heroku, we have this releases feature that shows you all of the releases you've made. Every time you deploy an application, every time you git push production master, again, your application code kicks off a release. We build your application by looking into your code base. You don't even tell us really what you're using. We support a large variety of languages, but let's say you're using Ruby. We'll look into your code. There are a couple of identifying markers we can see. Oh, this is a Ruby app. I know this, right? And we set up a server for you to run a Ruby application. We bundle up your dependencies. We set up your application configuration. All of that becomes a release. And that release goes and runs on the Heroku platform. So you can see here we have version 49 through 52. One of those versions was created by simply adding a AWS S3 key, because that's a release. We've changed something about the application in production. And all of these releases on Heroku can be rolled back just as easily as they're created. So you no longer have any fear of deploying to production like I did a long time ago and finding some error and then rolling back and having a 7-hour process where you're fixing the entire thing. You have a single command to roll back to a previous image. Because we're building each one of these releases as we go, we always have a good version of your application we can roll back to in an instant. Safest way to deploy to production. Processes, independent processes for your application. So each of these processes should live in isolation. And what I mean by that specifically, has anyone ever heard of sticky sessions? Is anyone using sticky sessions? Actually, don't admit that. But if you have used sticky sessions or are using them, you should stop. The idea here is that the HTTP is a stateless protocol, right? We're making an HTTP request to some user. I go to your website, and let's say you've got two servers, A and B, right? And I'm talking to server A. And you take my session data, whatever I've done on your website, and you store it in the local memory on server A. And then when I come back, you have something in your routing layer that says, we know Jonan was using server A, so let's keep sending him over there because we need to have access to that session in memory. This is a really, really bad idea because suddenly if you've created a dependency for me as the user on your cloud infrastructure, a specific piece, right? And if server A goes down, I'm going to be going over here and my entire session is destroyed. You should be using some kind of redundant store for those sorts of things. But that aside, Heroku enforces this by forcing you to declare the types of processes that you would like to start and how to start them. So for all major web frameworks, we automatically detect the platform and we can guess how it's supposed to start. A Rails application starts with Rails. This is lining in, this is closure. So this is how you would start a web application. But if we have a web process, that process is going to be serving the web request. We may also have a worker process. Let's say that you need to get an email. So you do something on the site that kicks off an email. That's going to happen in a background job. That'll be handled by a separate process. And each of those processes are declared in your proc file, and they're isolated. They don't share state because we treat them just like HTTP, right? They should never be expected to share state. If they do, that shared state needs to be persisted into a database or some other data store. You can look at all of the processes that you have running on Heroku right here with the Heroku PS command. You can see in this case I've got a web one running my Rails server and I've got a worker that's going through all of my jobs in rescue queue. Talk about port binding a little bit. So all of your services on Heroku will be exposed via these ports and you have control over that. You can put this port number in here into one of your processes and that other service then becomes available. And this means, of course, then that you can build these multi-application architectures, a service-oriented architecture, if you like, and those can expose themselves to each other as services. Port binding is a very important feature of a 12-factor application. We have concurrency. On Heroku, this is how you scale up. You take a process and you scale it to 2. So Heroku PS scale is going to scale up something. We're going to take the web process and we're going to go to 2. So we will now have 2 processes handling those incoming requests. 2 dynos, as we say. And a dyno is a bit of Heroku lingo, but you can just think of it loosely as a container. So rather than our one container, our one Docker container that you would be having out there, it's a dyno in our case, then you now have 2, right? And they're processing like this. This leads you to build your application in a very specific way, though, in that it can run in multiple processes. And that kind of concurrent application development is what you're going to need if you expect to scale. because of the way Heroku is built, you're going to build that way from the beginning because things are going to start to go wrong very early. If you turn on another web dyno and you find that you're not building the concurrent application you thought you were, it's better to find out before it's too late. So this is how you scale up, and you can drag this slider on the website. Everything I've shown you, all of these command lines, commands, these can all be done in the website as well. In the web UI, there's a little slider that's super fun to play with. You just log into the site and drag this slider up, and suddenly you've got 100 web processes serving your requests. Disposability, I touched on this a little bit earlier, but you should expect at any moment for server A or B or any of the servers out there that you have to die, right? And not even in a graceful shutdown sort of way. So we have a dyno as this container concept on Heroku, and this is how you restart them. Let's restart the worker 1 process. We say Heroku restart worker 1, right? Now that process goes down and comes back up, and it does perform a graceful shutdown. You see down below it says stopping all processes with SIG_term. If you have some cleanup you need to do, we help you take care of that. All of these processes will shut down gracefully. But the point of having this disposability factor is that you cannot assume that anything on that server is going to live on, right? Including the local file system. If you want to download a large file and parse through it and turn it into a CSV and put it somewhere else in the cloud, that's fine. But don't ever depend on your local file system on Heroku or anywhere else. All of these principles are designed to make your application the best it can be. People often ask me about Heroku. This is the #1 question I get when I'm at a conference is, where's the lock-in, right? How did you trick me into your walled garden and now I have to live here forever? The trick is it's really easy to use because we have features like this. And because it's really easy to use and we have features like this, it's also very easy to leave. There is no lock-in on Heroku. We're helping you develop a portable application that you can take anywhere. Your environment and your server are meaningless to you. You don't have to log into your server and install a bunch of things because all of those dependencies are available as part of your application code. It is part of your application. So we help you think along lines that actually defeat lock-in. That's disposability on Heroku. Development and production parity. This is a really important one. Remember I was talking about the salespeople with their staging server? This actually happened at the first company where I worked. We'd had this staging server, and then sales came to us one day, and they're like, oh, I want to demo some things for a call with a customer, so I'm going to load up a bunch of data this afternoon, and I'm going to have this call. And we're like, OK, great, go nuts. We're not using staging right now, right? Staging should really be in an environment that can be blown away at a moment's notice. One developer needs to use staging to test some new code or show someone else what they're working on. They ship it up to staging, and they deal with it there. This is not an environment that's considered permanent, right? So a salesperson puts in all of this mock data. Their call was the next day, which they didn't tell us. And of course, at midnight every day, we blow away the staging server and delete all of their data. And they were enraged. And that began the chain of other staging servers. So that we had actually 3. We had one we could actually use. And then we had the demo server and a sales demo server. So when you are thinking about developer and production parity, what I'm talking about is that your environment, your code, should all be the same between Jim and Kim's development environment, to staging, to production. That all needs to look as close as possible to the same. On Heroku, we give you the option to run as Heroku runs using a command called Heroku Local. So you can start up your Heroku application just as we will start it up on the production platform on your local machine using Heroku Local. If you can mirror those environments across all of these 3 stages successfully, or as many as you have in your pipeline, it becomes much easier to be sure that you're not deploying code that's going to break anything, right? So that pipeline that I mentioned, this is another thing that's built into the Heroku platform, and it's very easy to use. You have a staging environment and a production environment. You can promote builds between them. When you create a release from your, let's say that I'm adding a new feature, right? I've got the website up, and the boss comes to me and says, Jonan, could you make that blue button into a green button? And 2 or 3 weeks later, I learned some CSS, and I figure out how this is about like the scale of my coding ability. I just want to be very clear. I changed the color of the button, and I'm so pleased. And I put it up in a pull request on GitHub, and someone pulls it all down, and they check it out. And they say, no, Jonan, that's in fact yellow. That's not even close to what we asked you to do. And then we go back to the drawing board, and we start again, right? And we're iterating on this pull request. So what Heroku will do in that example is they'll actually put a button up on that pull request that says, click here to see what Jonan's code looks like in production. And because your environments are so closely matched, we can create a review application, a application that exactly mirrors what it would be in production that you can click on. There's a link right there on the pull request to go and browse around, and you can clearly see the button is not, in fact, the color we told you it was supposed to be, right? And so your cycle for making those changes, instead of hours or days or weeks, becomes minutes. It saves you a lot of developer time to have those review applications. And pipelines are how we do that. So when that application gets merged, let's say that they merge my pull request, I finally get the button the right color, it can automatically deploy to a staging environment. You can set this up on Heroku. So then it's in staging. And now the QA team can go and bang on it. Everybody can come check it out. Yes, Jonan changed the color of a button. What a great engineer. Good hire, team, right? So that promotion to staging, you can set that up to happen automatically. If you want to promote it up into production then, you've already got the build. It's already done. We already have all of the dependencies installed. Everything that is required for that application is living right there in that release that we've already created. So when it comes time to ship that out to production, you click one button that says promote to production, and you're live instantly with your new code base. That's your entire deploy process. Half of it happens automatically. You click one button and you ship to production. I think that's a pretty easy way to ship code. So that's our dev prod parity story. Here I am adding an example staging application to the pipeline. So I encourage you to play with pipelines. You can add applications in the various stages where you want them. You have different applications for different code bases, but in a single pipeline, you will always have the same code base and the same application. Obviously, there are changes that are happening in that code, right? I changed the color of a button, now my code base is not the same. Well, it's the same code base. The little bit of code that I've added should be as small as possible. And that's what's going to get you to that continuous deployment process that you're looking for. The way that you ship code with the least amount of friction is making small changes very quickly. You no longer have a 7-hour deploy process, and that's why you wait 2 months every time that you ship a new version of the production application, right? You could be shipping all day long, and Heroku actually offers a continuous integration, continuous delivery product to help you do that. Let's talk about logs and my first server. So I got a little cloud instance. I think it was on AWS. I set up my little S3, or my little EC2 instance, and I shipped my application up there, not even thinking about this logging piece, because it's not the sort of thing that occurred to me. And before long, I was unable to SSH into my instance. It turns out that I did not have any free space on the instance, even enough to create a little file handle to SSH in and look around, and I was locked out forever. Maybe? I don't know. I ended up making a whole new one and starting over from scratch. That's not how you should handle logging. There are a lot of steps between worst case scenario and decent logging. The point is that an application's output needs to go somewhere else other than the local file system, right? You don't depend on a local file system to keep that information safe, and it's invaluable for debugging. So on Heroku, you can tail the logs locally if you want to, but all Heroku applications, they output their logging information to standard out. So this is how you get access from the command line to standard out. But those add-ons that I showed you earlier, you could use an add-on to set up something like Papertrail, where you have searchable logs, and those also tie immediately into that standard out. And it's one click, it's a button. You just turn on Papertrail for your application. All of our add-on providers, almost all of our add-on providers offer free plans just like this one, so you can get on there and play with it. If you don't like it, you can turn it off again with that same button. It's very easy to use. But your logs, they are not part of your servers. They're not part of your infrastructure. They are the output of your application. It's your application talking back to you, and that needs to be stored someplace else other than there on that server. Admin processes. So with any application, there are going to be a certain number of tasks that you need to accomplish in an admin process. On Heroku, you can say Heroku run bash, and now you're running inside of that container that I talked to you about earlier. You've got a shell, and you can do whatever you'd like to do. So for example, on a Rails application, you may need to migrate your database from time to time. You can Heroku run Rails DB migrate. That will make your migration changes to your database. Anything that you could be doing if you had SSH'd into your instance, you can be doing on Heroku using these admin processes. And those should be distinct from the rest of your infrastructure. You shouldn't have some special dispensation for these processes or treat them any differently than what they are. They're just another process on the application, like your web and your worker, that starts up and goes away and does its work. Those are admin processes. That is, in its entirety, the art of the 12-factor application. So we talked about a code base. You have one code base now for all of your application, right? Your dependencies, you use a dependency manager, and more importantly, you use a dependency isolation tool, right? In the Ruby world, those two are the same thing. In some worlds, they're separate. But it's not just about installing all of your dependencies as part of your build step. It's also about isolating those from any other dependencies that may already be on that system. You have your configuration step. All of your configuration should be happening in environment variables. You don't have any reason to be getting in there and uploading secrets or passing them around. It all lives in the config. And that is all part of a release. The configuration and the application and the built dependencies, they are all a single release that effectively creates an image on Heroku that you can roll back to in an instant. You have all of your backing services set up as the services that they are externally. You don't depend on a database existing on a particular server or a particular version of that database. You have all of your backing services set up as environment variables, and you can connect to them using the connection strings. You build, you release, and then you run. And these 3 discrete steps are exactly what we've been talking about this entire time, but that build step creates your build. You take your build and you put it into production, and now that's a release, again, that you can roll back to, and then you run using one of your processes, like your web process, right? Maybe you have an application that is only doing background work. You have worker processes exclusively. This is fine. This is something you can do on Heroku. Port binding. These services expose themselves on ports that you control on Heroku. You have access to that environment variable, and you can tell us where that's supposed to live. Concurrency, scaling up and down is just as easy as anything else that you could do. But again, this is not just about Heroku. This is about how you're building your application. If your application isn't designed to be concurrent from the very beginning, you're going to have some real problems when you get to scale. And I know that move fast is an important thing to startups, but move fast and then die in a terrible fire is probably not as good an option. Please build concurrent applications from the beginning. Disposability. Your server infrastructure should be treated as disposable, not just because you may want to spin down one of those and spin up another, which is the case on Heroku, right? These dynos, they are transparent. You already have your image. You can put them wherever you want. But because your infrastructure may go down, right? AWS goes down sometimes. In that case, the internet is just generally broken, so you're allowed a day off. You can just go home the next time AWS goes down. You can tell your boss that I said so. But that's the disposability feature. Finally, we have developer and production parity. All of your environments should be as close to exactly the same as you can possibly get them. And Heroku can help you do that. Logs, please, please, please stop storing logs on the server. Put them someplace in one of these beautiful services that exist for searchability and alerting and tracking things over time. Very, very useful. And finally, those admin processes, they're nothing special. They're not snowflakes. They run off. They run. They go away. You treat them just like all the other processes on your platform. So those are the 12 factors of application development according to Heroku. Thank you very much. Really appreciate your time.